My name is Michael Boyle. I'm a security researcher and auditor at Quantstamp, a Web3 security company. And today we're going to be talking about money Legos in 2025, securely integrating DeFi projects using AI. So why are we doing this talk? Or this is what we're going to cover today. First, we're going to talk about why we're doing this talk. We're going to talk about the current state of integration documentation. We're going to look at solutions to improve the current state of the integrations, and then as well as a proof of concept looking at using LLMs to help developers integrate into more protocols. So first things first, we need to cover DeFi composability. We can think of DeFi as a bunch of money Lego blocks where each aspect of DeFi can build on top of each other. So in this chart here, we have everything on top integrates with the thing beneath it. So if we go all the way to the bottom, we have an ERC20 token called YOLO, and then on top of that, we have oracles that then pull the price for this YOLO token. Then we have maybe liquid staking projects, which then use those oracles, and then maybe lending protocols on top of that, and yield aggregators on top of that, so on and so forth. And so as we go up the stack, we have more and more integrations, which means that we have more risks, more consequences, and more trust assumptions that we have to be careful about during the development process. So in this example, say the ERC20 token YOLO is pausable and upgradable. This would mean that every single one of those protocols above them needs to be able to account for the fact that their token might not be transferable at some point. It might be upgraded to do something else at some point. And because of that, they need to be proactive decisions that are made during the development process to be able to handle any situation which can happen for protocols that you are integrating with. So another example, say this oracle has an issue. Now it has a stale price. This could potentially affect everything that integrates with it above it. So in this case, everything on the left side of the chart, we're not going to have to worry about. It doesn't integrate with that directly, and so it's not an issue. But we can see that even one thing going wrong partway up the stack is still going to affect a bunch of protocols, and this needs to be handled correctly. So here we have an example of two protocols that in some ways, or where protocol 1 integrates with protocol 2. We're going to say that a user deposits into protocol 1, and then protocol 1 does some kind of yield aggregation and then deposits the user's funds into protocol 2. And then we'll say for some unknown reason, protocol 2 needs to pause. Maybe they found an issue and they needed to fix it, or something happened with protocol 2, which then creates a unrecoverable denial of service in protocol 1. So now from a user's perspective, they see that I deposited into protocol 1, which interacts with protocol 2, but either way, I can't access my funds out of protocol 1 because of its integration with protocol 2, and it didn't handle it correctly. So now not only is protocol 1 going to be at fault for having a bug in their code, but protocol 2 is also going to get some of the blame and have a reputation hit because people didn't correctly integrate with them. And so that's mostly what we're going to be looking at today, is how to make sure that your DeFi money Lego has the proper considerations for how others should integrate with you. So obviously we're coming back to a topic that grew rapidly in popularity in around 2020. So we want to come back to it for a few reasons. Mainly, we wanted to look at the use of AI and LLMs to help solve this problem. Also, security knowledge in general has just become more well-known. The space is more mature, and so the documentation has gotten a lot better. And so since the ecosystem's upgraded, we want to come back to it and see if we can help out developers streamline this process even more and prevent integration issues going forward. So the first thing we did was we wanted to look at the current state of integration documentation. And so we have an example here where we're looking at a category of libraries. So these are low-level development tools that most Solidity developers have used at some point in their lives. We're looking at like OpenZeppelin libraries or the Solidity libraries. And we can see for both of them that they use documentation that is specific to developers that are going to be using these libraries. So they have warnings specific to some of the functions that they may use, and they indicate proper usage as well as common pitfalls that people might run into. And so these are very, very developer-oriented, but no user of DeFi protocols is going to be reading these.
Next, we have oracles, which again are a bedrock foundation of many DeFi protocols. And we can look through all of these oracles, and we can see both user and dev focused documentation, which is good because we want to see things where if they can be used by a user, it needs to have user facing documentation, but we also need developer and security focused documentation for any DeFi money Lego block. Finally, we looked at the documentation for another very common Lego brick, which would be lending protocols. So we looked at a few here like Aave, JustLend, Morpho. And our overall impression of these was that the developer docs were actually lacking. And we mostly see user-facing documentation, assuming that nothing is going to be built on top of these, which, as we've seen from many yield aggregators and swapping protocols and all kinds of stuff, it's just not the case. These lending protocols are used as a base for other projects and therefore should have security protocols and security considerations that are developer-facing and security-oriented to give developers the best chance to integrate with these protocols without having a hack. So just imagine that something that integrates with one of these lending protocols has an issue, and someone sees that their assets are technically sitting in Aave right now, but they're completely locked because the project that integrated with Aave didn't integrate correctly. Now the user is going to have a bad perception of not only the project that they deposited into, but also Aave. And so it's best practice for anything in DeFi to give integration recommendations at all levels. So we want to talk about the importance of composability guidelines and very specific use cases and how we want to have, what do we want the documentation to look like when we're integrating with a project. So these are some of the main things that we came up with. We need to have an exhaustive and correct and actionable list as possible. We need to have every action that can be taken by a user or an integration. We need to have it listed. We need to have its security considerations. We need to know things like, is the contract going to be upgradable or paused? If someone integrates with your contract that is pausable or upgradable, there's a very good chance that if you ever actually do pause or upgrade the contract, that you're going to break integrations and could potentially ruin something else down the line. Basically, anything that you use as a configuration parameter that is controlled by admins, that is not controlled by a typical user, can change the interactions with integrations, and so therefore they need to be accounted for. Again, we need clear warnings, we need clear and common pitfalls recorded, and they need to be easily searchable and LLM friendly. So in this case, that means that we need sections that are very specifically user focused, very specifically security focused, and very specifically developer focused. So here's kind of a situation of how it would look like when an auditor needs to audit a protocol that has integrations. So in this example, we have both contracts A and B, and we can say that A and B both have different builders and different auditors. If contract B was built first and then contract A uses contract B, if I am an auditor for contract A, then I'm hoping that not only did auditor B do a good job, but I also need builder B to have good integration documentation so that I can quickly reference how contract A should be correctly integrating with contract B, and how my contract can avoid any of the common pitfalls that might have come up from integrating with contract B. I also, unfortunately, can't take auditor B's word for it, or even the documentation's word for it. So these are all just general guidelines to get things going, but at the end of the day, we also need to manually review the code of contract B in order to be certain that contract A is correctly integrating with anything beneath it. So now we're going to go into a proof of concept where we kind of talk about using LLMs to help generate some of these security checkpoint lists that we're looking at. So we're going to use a project that is a standard lending project, and it integrates with Chainlink as its oracle. We anonymize the contract. It is from one of our actual audits, but we wanted to keep everything private and anonymous. So the first part of this check was we used an LLM query with the public integrations checklist provided by Chainlink. So we're basically going to take the documentation straight from Chainlink. We're going to take the contract code that we've audited, and we're going to give them both to an LLM and see, can it give us security recommendations based off of just the documentation that Chainlink has. And then second, we're going to give our own internal auditing checklist and see how that does as well. So there's a lot going on here. I don't expect you to read this all. This is just kind of a overview of what we actually gave to the LLM as context so that it knows obviously what the project does and how it integrates with Chainlink, as well as some of its admin control or functionality that might affect integrations. So here's what our prompt actually looked like. We say that for the smart contract above, is there any violation of any of the practices described on this page? And then we have a link to the Chainlink documentation about using Chainlink oracles. So what we get back from this is actually pretty promising. We see that we get concerns about data freshness verification. We don't want any stale data coming from the Chainlink oracle, and so we need to manually validate that within the contract. We see that it brings up the issue of single oracle dependency. So any protocol that uses oracles and needs data at all times should probably have some kind of data availability where we're using multiple oracles. We look at price validation mechanisms. So sometimes when an oracle has stale or outdated prices, we could get something that is way off from what's expected, or it'll even return 0. And we need to correctly handle that situation so that we're not adversely affecting users. We also see that it points out that there are administrative controls which could affect how the oracle, how it's receiving information from the oracle, as well as decimal precision handling, since not all tokens and not all data that is sent on-chain is going to have the same number of decimals that we use on-chain to represent the data. So then our second case study here was to use internal checklist that we've developed. Since we've audited so many different protocols and seen so many different DeFi and Oracle integrations, we have plenty exhaustive lists of integrations, or for integrations like this. And so we use our background knowledge of all of our audits to create our own checklist for things that we would look at when a project is integrating with an Oracle. And we wanted to see how this compares to Chainlink's actual documentation. So again, we supplied our checklist along with the code, and this is what we got this time. We get more of a question-based answer where it's saying we need to, or it's asking, kind of repeating the questions that we're asking in the checklist and then trying to answer it for us. So we see it ask things like, is the Oracle data up to date? Is the Oracle single source a failure, like we talked about before? Is the Oracle price hard-coded? Is the price feed for a similar asset used to represent another asset, which could be similar to, say, the decimal issue? And then any other, or I guess the decimal issue is the next one, but any other considerations that are similar to the previous one. So our takeaway from this was that you kind of need both. You can't always rely on one protocol to give you a good enough security guidelines that you can just feed it into an LLM along with the contract and assume that you actually are going to have all of the information that you want to need for the audit. You also, your list, if you're an auditor, even if you've been doing it for a long time, is not always going to be completely specific to the protocol that you are auditing. So just because it has a Chainlink integration doesn't mean that it doesn't do something unique or different with it than you've seen in previous audits. So ultimately, we always recommend using both, and then of course, a manual audit to cover in those gaps where you might have unique scenarios. So the conclusions are that we have DeFi security composability is an ecosystem level topic. We would love to see more protocols create composability guidelines that are security and auditing focused. And we want to reduce hacks. For many vendors, it's hard to find good security guidelines that are readily available and developer oriented. And I think a lot of protocols overlook the fact that they are adding to the DeFi money Lego stack. They're not necessarily going to be the last brick on the stack, even if they are at the time when they create it. So maybe right after you publish
your protocol, your next step would be to consider how someone might integrate with your protocol or aggregate your protocol and create a best practices list for others to use in order to prevent your reputation from being on the line if someone integrates with your protocol incorrectly. These are some additional resources if you want to take a look. And thank you for listening. I think we have a few extra minutes if we have any questions. Looks like we have a question. I'm going to have to ask you to yell it at me, and then I'll repeat it. So that is an excellent question. He asked, how do we make sure that the LLM is not flawed? Obviously, LLMs, especially at this stage, are known to hallucinate. And so this is why we still have to recommend that you do a manual audit in conjunction with using the LLMs. It's going to give you a good baseline. It's going to give you guidelines to start off of. But ultimately, you are going to have to double check it and actually do the work yourself. It's just going to help, hopefully remind you and help kind of create the checklist to start. Anyone else? Guess not. Thank you.